So good morning. Good morning from the International Relations Office of the Hellenic Mediterranean University, the Athena European University, and the Psy Cafe that has been planned together with Yorgos Kavoulakis and our International Relations Office. It's a great pleasure to have with us a very good friend, an ex-colleague in the Hellenic Mediterranean University, and now an associate professor in Aalborg University in Denmark, Yorgos Triantafyllidis. Some information about George, apart that he's a PAOK fan, this was obvious. He has received his bachelor degree in electrical engineering from Aristotle University of Thessaloniki in 1997. Then he received his PhD in image and video processing in 2002 from the same institution. In 2009, he joined the Applied Informatics and Multimedia Department of TI of Crete. And in 2012, he has appointed as an adjunct professor in the Department of Architecture, Design and Media Technology at Aalborg University in Denmark. In 2015, he appointed as an associate professor there and at the same department. He's a senior member of the Lighting Design Research Group at Aalborg University, focusing on how media technology and artificial intelligence are transforming the lighting design practice. More than this, he has research interests regarding the application of the BBL along teaching, and his work has received more than 1,000 citations and his H index is 15. Today, George will discuss with us and will present some part of his research regarding integrative lighting, understanding the visual and the non-visual effects of lighting on humans, a very important aspect from technology, but also from the medical point of view. So, George, the floor is yours. We would like to thank you. We are grateful for your time to be with us today. Thank you.
Yeah, thank you very much, Costa, for the nice introduction. And thank you, everybody, for being here today. It's nice to see some friends and ex-colleagues and new people. So today the plan is to give a brief introduction, and I will try to be very fast in order to have also some time for discussion. And the talk will try to focus to provide this fundamental understanding of the ways in which the light can affect health. And this is included in a new emerging topic, which is called Photonics for Health. And it's very nice, Costa. I saw that you went, I think you went to Milan last week or a few days ago. It was Photonics something. And Photonics.
Exactly. Yeah. And a lot of presentations, George, in this Carla event, which has been organized by the largest photonic centers in Europe. And the main purpose is like to promote various technologies applied to photonics to the students. So there were a lot of applications of what you are going to present right now about photonics in health. Exactly.
Photonics is a very big and very broad topic and can be very engineering and hardcore engineering with, and I'm also an engineer, so I know about it, but can also be very, with a very anthropological approach and also architectural approach, how photonics can have an impact to people and to the human's well-being. And just to give you another proof of the importance of the photonics is that DTU, which is like one of maybe the biggest engineering school in Denmark, they are going to change the name of the electrical engineering department to electrical and photonics engineering department. So photonics is going to get a lot of attention in the future, in the next years. And as I said, there are a lot of different topics and a lot of open room for new research and new designs. So today, as I said, I will try to introduce this integrative lighting, which is a new term that tries to combine the visual and non-visual effects of lighting on humans. And this becomes more important after all these new advances in lighting industry, like LED lighting and smart connected lighting, in order to bring some value to health and well-being. I'm always saying that and refer to health and well-being because the humans are always in the center, and sometimes integrative lighting instead of this term, we're using the term human-centric lighting. So if I can go on, the next slide is something that is very well known and we all experience, that now the human being is becoming in an indoor species. Although we have developed outdoors, now we're becoming an indoor species because we spend about 90% of our time indoors without enough daylight. So it's very important now to see the light and daylight and artificial light and how these two different lights can have a role in health and well-being. So there is this term integrative lighting, which is the main topic of this talk. And I'm having this definition from CIE, which is the International Commission on Illumination, an international organization. And the definition is that lighting, integrating both visual and non-visual effects and producing physiological and or psychological benefits upon humans. And this is something that is used from a paper from 2021, which is maybe the new way and the new approach for lighting design and for lighting engineering for solving issues for lighting. So there are as you can see, this is in this overview, there is the stimulus in the top, and at the bottom there is the effect, the response, and between these there are the different ways that light can affect people. So if we take like a minute to check in more details this methodology and this diagram, we can see that on the top level there is the temporal pattern, which relates the timing and duration of exposure to a light stimulus. There is the light spectrum that refers to the spectral power distribution. There is the light level, which is the light, the intensity of the light that we get. And finally, there is the spatial distribution, which is how the light is distributed in the three-dimensional light field, space. So we have these four stimulus, there's four causes that are related to the light. And then we can see that there are two different pathways, as we call them, the visual pathway and the non-visual pathway. So the visual pathway is related to the visual performance, visual experience, and visual comfort, while the non-visual pathway is related to the acute responses, circadian responses, and long-term responses. And all these are actually having an impact to humans regarding visual, circadian, neuroendocrine, and neurobehavioral responses. In order to categorize these two responses, as we say, we have the visual and non-visual responses, which are driven by some photoreceptors that we have in the retina and send signals to the brain. So what we can say is that the visual responses in humans are largely driven by rods and cones, some photoreceptors that we have in retina, while the non-visual responses are largely driven by some specific cells, which are called Iprgs, that means intrinsically photosensitive retinal ganglion cells. And these are responsible for the non-visual responses, which sometimes we call them also non-image forming effects, or biological effects or physiological effects. So we have these two very different ways how light is affecting people, and we were very aware of the first, of the visual effect, but now we are understanding more and more, and there is an ongoing research also in biology and in medicine, how to understand the non-visual effect of light. And these are some examples of physiological and psychophysical responses that are important to human health, well-being, which are influenced by light and lighting over different time periods. So you can see, for example, and we have this categorization about immediate, delayed, and long term. And you can see different examples of responses, for example, from the visual discomfort. So when you have strong light headed to you, then this can create some visual discomfort. And the psychophysical, as we said, are largely driven by the visual pathway. And then we have the physiological responses like the circadian phase shift, the sleep quality, the stress, the depression, which are driven by the non-visual pathway, because there is another pathway that can affect all these responses. In another, again, this is more or less the same, but we're trying to model these factors and these responses into these 5 main categories. So we're talking about the visual performance, about the visual experience, visual comfort, circadian phase shifting, and alertness. So this is a new paradigm, the new way when we would like to evaluate, when we would like to assess lighting for humans. So if we want to have lighting for offices or in schools or in hospitals, these are the 5 parameters that someone needs to take into consideration in order to use them and evaluate the effectiveness and the efficiency of the specific lighting. And as we have said, the first, maybe for the first 3 categories, the performance, the experience, and the comfortability, there is a lot of research the last decades, and these are actually the basis for the lighting industry standards, the recommended practices and guidelines. But it's not the same for the last 2 factors, which is the circadian and alertness, which are now, as we said, trying to understand how they work and trying to evaluate the impact of lighting for these 2 specific factors. So let's start with circadian lighting, which is a very, very important topic and can affect a lot the quality of life of people. So circadian lighting actually means a lighting system that is designed to follow the internal human biological cycle. And this cycle is called circadian rhythm. And this cycle is also encoded in our DNA. And there have been research that also different other animals and or even people from different countries and cultures can have a little bit of different cycles. So for example, North European with South Europeans can have a little bit of different, it's not that big difference, but there is some difference in this circadian rhythm. But let's see some proofs that it's always nice to understand the importance of circadian rhythm. So first of all, there is the jet lag, which is the official term is called circadian dysrhythmia. And we have this, which is this physiological condition where we have this rapid long distance travel that can result in problems, in alterations to the circadian rhythm. Another example is the camping. And if we do camping after a few days, we'll probably wake up with the sunrise and fall asleep with the sunset. So we'll follow this cycle of the sun. But what is actually happening now, thanks to electrical lighting that we have access whenever we want, we have these kind of alterations in our circadian rhythm. And finally, it's maybe the best example is the babies, which are born without having a fully functional clock. So fully functional circadian rhythm. So at random times of the day, they can sleep, they can wake up. So it's very a random cycle. So, but luckily as humans, when we grow up, we evolve this circadian rhythm and this clock. So we have this constant cycle being active and feeling sleepy and get some sleep. And the most important reason for this is, and the message, the stimulus that we get is from the daylight. And finally, this is the Nobel Prize in Physiology or Medicine 2017, which was exactly for the topic of discoveries of molecular mechanisms controlling the circadian rhythm. So in this figure, you can see a very brief illustration of the circadian, of this clock of human body. Of course, this is a generalization, and I'm going to discuss also about personalization and how there are some differences between people, obviously. So we can say that when we have this high alertness, which is around 10 o'clock, the best coordination is about after the noon at 2:30. And we have at 9 o'clock, we have this melatonin secretion starts. So the melatonin is produced in order to feel sleepy and have some sleep. Let's check some biology in order to understand the whole context. And the thing is that plays the most important role in this kind of getting of how light is impacting the circadian rhythm is based on a protein, which is a blue light sensitive, which is called melanopsin. And this protein is more sensitive to blue light and less sensitive to orange and red light. And this melanopsin, as we said, is found on these Iprgs cells. And these specific cells is connected to the non-visual pathway, and these cells are connected to this SCN, the suprachiasmatic nucleus, part of the brain, which is responsible for different functions of the body, like the sleep, the metabolism, and controlling the hormones. So this is a very important part of the brain that controls a lot of important functions in the human body. So what is going on actually, in order to fully understand the whole process, is that we have this melanopsin, which is activated by the short wavelength, which is blue light, short wavelength component of light, which is blue. And then what is happening is that this melanopsin, when it's activated, then it suppresses the melatonin synthesis. So what should be done is that, for example, during the evening, we have candlelight or very low light. So melanopsin is not activated because we are missing this blue light, strong blue light. So the brain thinks it's dark, the melatonin is produced, and then we can have good sleep, because the melatonin is a very important hormone that is needed in order to have good sleep. And maybe, I don't know if you have, for example, here in Denmark, which is a big issue about winter depression and the quality of sleep. There are a lot of even melatonin pills that you can get in order to support the melatonin production of the body, exactly as you can get vitamins and things like that. So the melatonin is very critical and important to have good sleep. And then likewise, in the day, in the morning, the daylight is very rich in blue light. So that means that the melanopsin is activated and the melatonin drops. So we feel more energetic. And also there is another hormone, which is called cortisol, which is needed in order to feel more energetic. So this is how it should, the body should work. But what is actually happening is that since we spend a lot of time indoors, in the evening time, we have a lot of screens, we have a lot of bright light that activates melanopsin. So we don't produce a lot of melatonin, and then we have poor sleep. And also in the day, during the daytime, we don't get enough light, which is rich in blue light. So brain thinks that it's not day yet. So we don't feel this kind of energy. And this is very typical, especially in Scandinavia, when you see this kind of gray and not daylight. You can feel that, okay, you don't feel this energy that maybe you can have when it's a bright day. And this is something that we all feel and we all know. It's not like rocket science or something that we don't know, but it's very interesting to see and understand the mechanism, how this works and why we feel more energetic and why we feel less energetic during the daytime, or about the quality of sleep, which is also very, very important for people. So as maybe you understand, what is very important is the spectrum of the light. So it's because this also makes some differences for the melanopsin, activates the melanopsin or not. So it's very important in order to see to analyze the spectrum. And now all the lighting design approach is going towards analyzing the spectrum. It used to be a few years ago only about the color temperature and about these type of things, but now we are focusing exclusively, I would say, to the spectrum. And even you can see for the natural light that there is a different spectrum during the daylight or in the morning, where you can see more blue wavelengths compared to the sunset, where we have less blue. So that's why, obviously, you can get, as we were explaining before, better sleep. So the idea and the goal is to somehow, and this is the circadian lighting, to somehow follow this pattern, this spectrum pattern of the daylight, also with artificial light. So there is a big research about circadian lighting and how beneficial can be in people, from age-related needs, mood, cognition, alertness, sleep, and improve well-being in general. So let's focus about the methodology and the metrics. As we said, the most important thing is about the spectrum part. There is a typo here, spectrum power distribution. And you can see the big difference, for example, about the daylight, what you get, how rich the daylight spectrum is. And if you compare it with incandescent light or fluorescent lighting, or even with some cool or warm white LEDs, you can see the big difference. And this actually makes huge difference in how the specific light source can affect the circadian rhythm and this non-visual pathway that we're discussing. Even just to give an example, even when you get a Philips Hue and you try to simulate the evening or the candlelight or the noon, you can see that even if visually you get exactly the same light, the spectrum is not the same. And the spectrum does matter because what we were explaining before. So it's very important to try to work on the spectrum and spectrum distribution of the light sources and make them in order to respect the human needs. Now I will go into some more details, but I will try to be as comprehensible as I can. Actually, as we said, and this is something very helpful because it's like a model that helps us understand the impact of lighting. So we have these 5 photoreceptors groups in the human retina, which is the cones, the rods, and the Iprgs. So the cones are actually, maybe you, the people that maybe have some experience with image processing or with the human visual system, are the photoreceptors in the retina that can give us the color vision. So we have the S cone, the M cone, and the L cone, and each one of these cones are related to the RGB colors. Then we have the rods, which are a type of photoreceptors which are sensitive to light levels. So these give us the intensity of the scene. So it's like in order to see something, for example, even in low light. And finally, we have the Iprgs, which is the new thing, which is these cells are expressing the melanopsin photopigment and how light can affect this specific this specific protein. In order to do that, there is a new metric which is called EDI, equivalent daylight illuminance, and this is defined as the illuminance produced by radiation conforming to the standard daylight that provides an equal aopic irradiance as the test source. So when you have a light that is giving exactly the same irradiance like the standard daylight D65, which is like a standard daylight, then you have a value of 100. So as you maybe can see in this graph, I don't know if you can see my cursor, this is daylight. So these are the different S, M, and L, and rhodopic, and the melanopic is the new addition, I would say, that we're focusing for the circadian lighting, and it's 100. And then for your calculation is 63. And that means that your light source is less efficient compared to the daylight. So the goal is to make it according, of course, to the case, because during the daytime we want this melanopic EDI value to be quite high, and I'm going to this in a while. And during the nighttime we want this melanopic EDI value to have a lower value, because we don't want strong daylight during the nighttime, obviously. But this is something that is evaluating actually the impact of the specific light source that we have. So in order to do that, there is a CIE toolbox which analyze the spectral data and make these calculations in order for the EDI. And there is also, just a few months ago, there is from the Oxford University, there is a new a web interface of this toolbox, which is very practical and very nice to use. So what you can do is to get the spectrum of the light source and feed it to the system, and then you can get how efficient and how effective this light source is in terms of the circadian response. And this is a statement from 2019 from CIE, which is the proper light and the proper time. And this is very, very important to understand. So we don't need a constant light, and we have, as humans, we have different needs in different times. And this is actually what the daylight does also. We have different daylight in the morning, in the noon, in the evening, and during the nighttime. So what needs to be done is, and I'm reading from the slide, a high melanopic EDI during the day is usually supportive for alertness, the circadian rhythm, and the good night's sleep. And a low melanopic EDI in the evening and at night facilitates sleep initiation and consolidation. And of course, for the last paragraph, is that this is always something that there are some factors, because now we are talking about the factors of the light, but also there are some factors of the people, about age, about different characteristics of people that can affect the impact of different light sources. So the problem is really problematic, is really big and advanced, and the problem is difficult to be solved. But at least now we have some kind of models in order to, at least to understand what is the mechanism. And this was an outcome, a paper that is not yet published, that is providing some specific guidelines for the melanopic EDI, exactly as we have guidelines, for example, for open spaces where we need like 500 lux in the table for offices. In the same, likewise for the melanopic responses, when we are checking the melanopic responses efficiency, then we can say that for the daytime we need at least 250 lux melanopic EDI, and during the evening time less than 10 lux, and during the nighttime we need less than 1 lux. And when we say lux, now we don't refer to photopic lux, but to melanopic lux. And just to give you an example, this is from a website that we can run some simulations. And as you can see here, this is the light that we get from the screen of an iPad Pro. And you see the S cone, the rod, M cone, L cone, and the melanopic. And you see the different lux values. And S, rod, M, L, all these are photopic. And then we have the melanopic, which refers to the non-visual pathway and what is the melanopic response. So we need to check this specific number. And this is another case in order to show you the importance of this melanopic EDI. So here you can see the light that we get from a MacBook Air. And when we have enabled this night view, there is a specific function in Mac OS operating system when during the nighttime you can block the blue light of the screen. So when we enable this, you can see, so the screen becomes more warm. You can see that the melanopic it's getting higher, and here in this one it's lower. There is a very nice software which is called Alpha software, which allows us to simulate and model and make calculations. And this is actually a plugin for Rhinoceros software. So we can make all these simulations and calculations regarding the melanopic response that we need to check. And besides the EDI, there is also another one metric that is used quite a lot, which is called Circadian Stimulus. And for this, what we can say is that we need to have at least 0.3 or greater at the eye level, at least 1 hour of the day, in order to get enough energy. So this is the guidelines regarding this specific metric. So now, I hope that you got a brief understanding of the importance and what is exactly the melanopic response and circadian rhythm and lighting. I would like to show you very briefly some projects that we're working in the lighting design lab at Aalborg University. So we have some, we're focusing a lot how to create circadian lighting and good lighting for people, for elderly people or people with dementia. We have circadian lighting for people with eating disorders, for students in classrooms, students with OSD or in the spectrum of autism, and circadian lighting for offices and night shift workers. So there are really a lot of different applications in order to try to optimize the lighting and provide better lighting for people. So for lighting for elderly people, this is a very big topic in Denmark and also in Europe, since there is a big interest in technologies and designs that can support the elderly people, and especially since elderly people are spending a lot of time indoors. So we need to deal with the problem that the elderly people are lacking natural daylight. And up to now, the lighting systems in elderly houses was only to support the visual needs of people. But as we said and we discussed previously, there are also the light is needed also for the non-visual things like circadian rhythm, alertness, quality of sleep, etc. So it's very important, and for elderly people that also suffer from pathologies and other problems, this can make a very big difference. So we had this project, which was called Lightel, and we have different groups, people with dementia, with reduced mobility, with reduced vision, or with just general age conditions. And the goal was to improve well-being of elderly using circadian lighting. We applied a very typical circadian lighting plan where it was in the morning more cold, and it was going colder and colder, and then during the evening time it was going more warm, and during the night time we had this orange-red light of low illumination. at low illumination level. And for the analysis of the results, we had a holistic approach, and we had some sensors. We use sensors in order to track activity detection by using actigraphs, and anthropological in order to see the mood and observe the mood, and also we made some interviews, and medical in order to see the biofactors, how the different levels of hormones can be changed. I'm going to skip these slides because we have a specific report about this project. These were the sensors, the medical factors, the anthropological factors. Maybe I can go very briefly to the results. And we could say that maybe the most important thing was that by having this circadian lighting, the residents started to follow this cycle and get a more constant rhythm. So time to wake up, time to rest. And this is something also quite expected, I would say, that if you are in a room without daylight and you have only the same artificial light, it's very difficult to understand when it is day, when it is night, and especially in the Nordic countries when we have these kind of long nights during the winter time or long days during the summertime. So this is very, very problematic. So using circadian lighting really helped a lot in order for the people to get like a day rhythm and have a time to wake up, time to rest, etc. Also, it was more cozy and relaxing atmosphere. So they know, for example, when to eat, when to go for a walk, when to go to watch TV, and all these things. So it was much better in order to create this daily schedule. Regarding the people with dementia, this was an observation from the staff that was very beneficial in order to reduce distress. So the people with dementia seem to be less stressed by having this light, which was really impressive, to be honest. Then about the light, this was something that also was found during from the medical analysis, that during the nighttime, when we didn't have this kind of strong light in the bathroom, for example, because elderly people are visiting the bathrooms a lot of times, and if you have blue light or strong light, then this can create a lot of problems and alterations in the circadian rhythm. So we used a low level red orange light in the bathrooms, and this helped a lot the people to get better sleeps. But in general, of course, the people had, there's this term called technophobia, which is, especially for the elderly people, to use new technologies is very difficult to adapt new technologies. But the staff was very helpful, and it was really nice to see the positive impact at the end of this project. After this project, and this is an ongoing project that just yesterday we made a presentation about it, and this is in collaboration with municipalities of Copenhagen and Aarhus, which are the two biggest cities in Denmark. And this is the goal of this project is to create a light fixture that can provide this integrative lighting for elderly homes. Here in Denmark, there are a lot of elderly homes that are controlled and managed by municipalities, so the elderly people can go and live there. And it's very important for the municipalities to provide to these people, elderly people, some good lighting, so that can be beneficial and can support the well-being of elderly people. So this is an ongoing project, and again, it's about to evaluate and check different light sources and different ways of circadian lighting, because now we are in a level where we can say that circadian lighting is very beneficial. Now the challenge is to find which specific circadian lighting is the optimal one. And this is maybe the holy grail now, and the big research question for all these projects. And we're trying to have these quantitative and qualitative methods in order to, as you can see also in this graph, so we are measuring EDI and photopic, and we try also to combine visual and non-visual impact of lighting, because of course now in this talk I'm focusing on the melanopic, on the non-visual impact, but also there are, if you remember, also these three categories, three groups of visual effects of lighting, which also need to be considered always. Now this is another project that we had 2 years ago, which was about circadian lighting for people with eating disorders. And here it goes to see how the circadian lighting can be used as a part of the treatment, not as a light therapy, because there is also this light therapy when you stand in front of strong light in order to get enough light, but use lighting in rooms, in residential houses, or in rooms where you live, in order to get the best results out of these light sources. And we applied this circadian lighting to a department of the psychiatric hospital of Copenhagen, where some people that are suffering from anorexia nervosa and bulimia nervosa are staying there for a short term for about 10-15 days. So the pilot was, as I said, to apply this circadian lighting, and it was to understand what is the impact of this new different type of lighting compared to a constant typical LED lighting. So this was here, we went one step ahead in order to try to evaluate. So we had the typical, like the control approach, which is a typical LED lighting, not controllable and just a constant. And then we had a circadian lighting one, which was high intensity in one long peak, as you can also see in the graph. And then we had this the circadian lighting 2, where you had these two peaks, as you can also see in the graph. And it was very interesting. We didn't find any difference between the two different lighting, circadian lightings. Of course, it's always difficult about analyzing data, and it was only for the fact that these people were staying only for 10 days. It was quite difficult to make a more strong statistical analysis, I would say. But what we found, which was very interesting, it was to see that there was this direct correlation between the high core temperature and the high lux intensity, the high intensity of the light, and the high levels of physical activity. So when you had more strong light and more cold light, then this was resulting in more physical activity from the people, which was this, especially for people with suffering from eating disorders, is very important, because these people tend to want to move a lot, to have this kind of continuous movement. So by lowering the light levels, this can help a better atmosphere for the people in order to not to have this kind of very strong physical activity that they tend to have. This is another project about circadian lighting for students in classrooms, and this was like half a year ago, and we still have in next month we're going to have some more experiments. And this was in order to understand how light is impacting by measuring the EDI, the specific classrooms. So we did some measurements in 3 different schools and in different classrooms, with fluorescent lighting, with typical LED lighting, and with controllable LED lighting, where you can have different levels and different CCT, different temperature of light. And what we found, that when you have this fluorescent lighting, there is not enough melanopic output. And this is very important result, that when we have fluorescent lighting, the students are not getting enough stimulus from the light in order to have this hormone production to suppress the melatonin and produce the cortisol and feel energetic. So this is a very big problem. And now, especially in Denmark, there is a big discussion about lighting in schools and how to do it in the best way. The LED lighting, again, the situation was a little bit better, but again, it was not enough melanopic output. And in the only case where we had some decent melanopic output, when it was in the LED controllable lighting, in the focus mode, when we had good results for the melanopic output. But of course, there are also a lot of other parameters like orientation of the classroom, the access to daylight, for example, window size, etc., and the position and where the desk is positioned in the classroom. But we did some measurements. Actually, we had a lot of measurements in the classroom, and it was quite sunny day outside, and still for the fluorescent lighting, it was really problematic when you had for some classrooms. Another very important topic is about lighting for students with in the spectrum of autism, and this is a very big topic, and there is a lot of research how to support people, and since there is no treatment to cure ASD, and the question is how light can help the atmosphere especially for students. If we can start, we can say that people with ASD can be either hyper or hyposensitive. So hyper means that that can be more sensitive, and hypo means less sensitive. One very important factor for ASD, for people with ASD, is the flickering. Flickering is how the light is the strobing of the light. So usually some people with autism can see even 60 cycle flickerings, and this is typical with fluorescent lighting, and this can lead very much to headaches, eye strain, and in general problems. So flickering is something that needs to be checked, and I can also relate to these experiments that we have done in the schools that I discussed before. And it was the flickering, even for people not having ASD, in one classroom was so bad that we contacted the school administration and said that, okay, this is really bad, and this classroom suffers from a lot of flickering, which is really bad for the students. So flickering can result in headaches for all people, but especially for people with ASD, these people can be even more sensitive. Then there is the dynamic lighting, which is the people with ASD tend to have to focus more to dynamic, natural-based biophilic patterns. So this is something that we also need to consider in designing. Then we have the hues, the colors, and usually we have this kind of more soft and earth tone colors that are better, not strong, intense colors. This can create more anxiety and are not very well received by people with ASD. And then maybe this is the most important about the use of fluorescent lighting. And there are some, I'm going to show you in the next slide, some surveys that fluorescent lighting for people with ASD create a lot of problems, and because of the spectrum, because of the flickering, because of the, I think that we don't know yet why, but it seems that the spectrum can play an important role for this bad result. And this was a study from 2020 in US, when they replaced fluorescent lighting with LED, and they had very much better results and how the students were behaving in the classroom. And this was another one in 2021, I think, where they replaced fluorescent lighting and they had programmable circadian lighting in homes of children with ASD. And again, the results were very, very positive. So this seems to have a very beneficial effect for people with ASD. Very briefly, and I have some very few slides and more circadian lighting for offices and night shift workers. And this is another very important topic. And we say that morning light or daylight is needed to regulate the circadian rhythm. It's very similar to a cup of coffee. So exactly as when we get a cup of coffee and we feel more energetic, the same applies to the good daylight in order to make us feel more energetic. So workers that are exposed to circadian lighting in general who have this better sleep, we have more energy. So it's very important. And in Denmark, almost all municipalities now, they are using circadian lighting in their offices for the people that are working in the municipalities, which is very, very, very good. And again, I have heard a lot of positive feedback by having this circadian lighting in offices. Of course, there is this challenge of the night shift workers and how you can deal with light. This is also very related for what we're discussing for the jet lag, for example, before. So here there is a problem because night shift workers has been related to health problems and of course decreased performance. So there is a lot of research now. We don't have any specific project up to now for this problem, but it's a very nice research topic in order to see how you can optimize lighting and support the people that are working during night. Conclusions. Where we're now is that the circadian lighting has started to be applied. We started with the hospitals because this was something like very specific and very clear, but now we have circadian lighting also to workplaces, schools, houses, wherever, in order to improve and benefit people and help people feel better. Where we are now and what research should be done. So now we are focusing and we are in a level that we understand much better the light factors. What now we need to do is to see also the people, and what we are talking about personalized factors and different age related, for example, etc. So there are these three factors that as research group, we are working a lot, which is the optimization. So we have different challenges for people with ASD in classrooms, for elderly people, etc. So it's optimization according to the case. No, optimization. Sorry, I was referring to localization, which is the specific setting, the specific case. As I said, the elderly people, the school, the ASD, etc. Then we have the optimization, which is which circadian lighting is the best. And this was what we try to do with the people with eating disorders when we tested different circadian lighting schemes. And now we're trying to do the same with this project with the municipalities of Aarhus and Copenhagen to find the best, the optimal circadian lighting that we can have. And finally is the personalization. So how we can make it more personalized, so people are different, have different needs, so how we can also take this into consideration. So there is this new approach. So now the lighting is not only for visibility and the visual needs, but it's much more complex and advanced and more needs that needs to be considered. Of course, there are more needs about circadian lighting. There is the double dynamic lighting, and I'm going very fast on these terms, which is how to combine the daylight and the artificial light and integrate both of them in order to provide a solution. We'll have a project about it. Then there is the impact of the view, the daylight view and biophilia. So there are a lot of research, for example, for the hospital, there is this metric, which is the average hospital stay. And it was found that when you have a window that is looking to a green area, you stay less days in the hospital compared to when there is a room without any window, which is really impressive. So there is this the view and this biophilic pattern, the tendency that we like natural patterns are very important. And there is a new standard which exactly is discussing this, the daylight provision, the view out, the sunlight, and the glare factors for the lighting design. The flickering is also something very important, as we discussed also, for example, in the case of people with ASD, but not only. Flickering can, and also I can tell you a lot of stories of headaches when we're trying different light fixtures, and after 20 minutes you can start having strong headaches because of the flickering. And final comments, LED lighting is actually allows us to do this better programming of artificial lighting and allows us to do more things. Circadian lighting is very beneficial to people, but now we have these challenges of optimization, localization, and how to make it. I forgot the third one. It's localization, and I will go back. And personalization, optimization, localization, and personalization. Now I got stressed because it took me more time than I was expecting, so I'm trying to be fast. And so final comments, I'm here. New metrics in order to understand and evaluate this non-visual impact of lighting. And yeah, I have it also here, personalization, localization of lighting is the next big thing. We have this project, which is an Erasmus project, very nice, and you can go to this website, course lightforhealth.net, where we're discussing this state-of-the-art topics of this new approach for lighting design and how light is impacting humans. And that was it. Thank you very much.
Thank you very much, Yorgos. We can skip this image, so you can stop sharing your screen if you don't mind. Excellent. Thank you very much. I got a lot of ideas, but when I was noting the ideas, then another project you have done. So another project you have done, but still, I have some for a new project.
Yeah. Always, yeah.
And I will give the floor to the audience. I know that we are a little bit late. If there are any questions, I have some questions myself, but in the case that the audience has some, the floor is yours. I can see my colleague, Associate Professor Manolis Maravelakis from the Department of Electronic Engineering. Manolis, the floor is yours.
Okay, thank you very much, Georgios, if you allow me, because we are also colleagues. We studied the same department in Thessaloniki, almost the same years. I finished about 3 years earlier.
Oh, really? Oh, okay.
Yes.
He was a basketball player.
With
He was a basketball player.
Ah, yeah, you told me. Yeah. Okay, cool. Nice.
It was a very nice presentation. I really learned new things about non-visual effects of lighting. Actually, it was my question on the Menti page where you sent us what is this kind of effects. My question is since you have told us that we are, and I agree, of course, that we are indoor species, there are huge markets on the lighting. And my question is how market and big companies are reacting to this kind of new research. And when are we expecting to see new lights that can incorporate this kind of research, and the lights can be programmable to change spectrum for different kind of needs?
Yeah.
These are my questions. And you mentioned also Philips Hue. Is Philips one of the pioneers in this area? If yes, why it's so expensive? It has 5 times the price like the other products.
Yeah. Let me start with your first question, which I think is very nice and very important. And I would say that because we are working a lot with companies, and especially in Denmark and Sweden, I would say that in Europe, the pioneers in lighting industry is Denmark, not pioneers, that the countries with the biggest companies are Italy, Germany, Denmark, and Sweden. These are maybe the countries which have very big lighting industries. And we have so many collaborations, and all of them are talking, this is like a buzzword, that are talking about human-centric lighting. And when they're talking about this human-centric lighting, is about this kind of lighting, not only for the visual needs, but also for the non-visual needs. And I can refer to Zoomtobel, which is maybe the biggest company, and is Austrian Germany company. And we have this project with them, which is the double dynamic lighting. But if you go to the websites, they are always talking about this human-centric lighting, that they are talking too much about it, that in the research community now there is this kind of, okay, we have overused this term and don't use it anymore because it is used from industry so much. So that's why we have this integrative lighting. So I think that it's coming now. Maybe you can see also some products that can also Philips Hue and all these things. They have this circadian lighting that they can follow the circadian, the daylight settings. But of course, it's not that easy to simulate daylight. There are a lot of also LED producers that are trying to simulate daylight and have this spectrum. When I say simulate, I'm referring to the spectrum reproduction of the daylight. But it's coming, and they have some very good light fixtures that, of course, now they are very important. And you mentioned about the price. And that they are very expensive. Of course, now Philips sold this to Signify, which is another company. So now Philips Hue is owned by another company which is called Signify. And of course, there are some relevant and similar products which are less expensive. But still, I think there are more questions about interfaces, about connected lighting. There are more things, and it's not only about circadian lighting. So when we're talking about industry, there are even more things. But circadian lighting is going to be a very important role. So in the near future, when we buy a light, and we're going to see how many lumens or lux you're going to have. You're going also to see how many melanopic lux you're going to have. And maybe we can talk again in 5 years, and let's see if this will be the case or not.
Thank you very much, Yorgos.
Yeah, thank you.
Thank you, Manolis, for the question, Yorgos for the answer. I have a question regarding, the new technologies, and because the cost is very important, and if you would like to make this in real life a human-centric lighting, the cost should go lower. Regarding the consumption, the production, first of all, the consumption, etc. So there are new technologies like the organic light emitting diodes that they can play a role, that the cost is much lower, the purity is much better, and the installation is much is easier, and also the replacement. So do you have any ideas about the impact of organic electronics or this kind of technology, the printed electronics, what was the impact to what are you doing?
Yeah, now there are a lot of some that, because in my talk I try to focus on the impact of lighting, but the light source, as you understand, is very, very important. So the different types of LEDs, the organic LEDs, or the photonics engineering, how to produce LEDs is very, very important, and how to control and how to drive LEDs. For example, one of the basic factors for flickering is the bad drivers of LEDs. So the installation is very important. So it's the approach should be production of LEDs, evaluating and applying in order to see the impact of LEDs. The good thing is that now we know how to evaluate much better, and we don't only wait for we know the mechanism that we can understand. We are also using EEG. We have some experiments and some recently we published something, and we are currently working on something more, how to use EEG in order to understand the impact of lighting and the effect of lighting. So there are very, very important things to check. And that's why I said that photonics is so broad. It's one part, the production, the photonics, the LEDs, which is very engineering. And the other thing is the next step, I would say, is the application and how you can take advantage and can benefit specific people and cases. But you asked also about the cost, and there is the question that we get from municipalities and schools administrations is, does it worth to make a new installation of an expensive lighting, LED controllable lighting or not? This is not the only, but the basic question that we get from people. And of course, it is much more expensive, the installation, or more expensive it is.
George, I mean, the automobile industry shows, it has the answer. From the moment that, all the lamps, in the automobiles, they have been changed with OLEDs because of the efficiency, the cost, and the duration of life. This is the answer. I mean, they don't need, the municipalities to ask you. They can go to BMW, Audi, Toyota, and, there are the reviews over there, how efficient and how lower the cost is, like replacing old lamps with LEDs.
You see, but this is for the new cars. What is going on for the old cars?
Because but it's a matter of cost and lifetime.
Exactly. I mean. This is because the question that I'm referring is that you have an old car. Is it worth to change the light bulbs of the old car to OLED or not?
The same question can go if you would like to have high efficient energy buildings, and what are you doing with the old ones? I mean, you have to face, in some case, in some instance, the new challenges.
Yeah.
I mean, this is. I have another question, and very fast. I would like a very fast reply, if this is possible. Like, yes. What about the spectral purity? You mentioned like blue light, but what kind? I mean, there are different blue lights. For example, when Nakamura in 2004 invented the gallium nitride blue light, it has changed completely the industry because of the purity, that very, very good blue light. So how the spectral purity impacts on the efficiency of controlling, let's say, the insomnia, which is a very big issue regarding the efficiency of the people, and has an impact to finance?
Yeah, that's a good question. And the answer is that we don't know yet exactly.
Okay.
We know that somehow the blue, these cells are sensitive to blue, but this is an ongoing research in order to fully understand from the blue and what is going on. And also more is because we are talking now about the visible spectrum, there is also the non-visible spectrum that also can affect. Mm-hmm. So it's something that we are still trying to know exactly the mechanisms. This was something very recent from the 2017, and maybe there was another one from the 2014 that was, they found these cells that are blue sensitive, but still they are trying to find out the exact, because what we're asking, I guess, is the weight of, about the blue. So
exactly. There are a lot of blues, let's say.
Yeah.
Okay, excellent. And last one, sorry about the audience. I know that I'm not polite right now. What about augmented reality? How can help, fighting, for example, the jet lag? For example, if you are traveling to the US and you're wearing, some goggles, and in order to help and create some augmented reality environment, does this help in order to fight very fast the jet lag?
Yeah, this it's funny because this is one of the ideas for projects.
Don't say that. It's mine now.
And because there is a question if the VR is actually affecting the same like the real world.
Exactly.
And the idea for the project is to do this comparison for EEG in order to see what we get.
Okay, excellent. So I will give you a call later on, and I will set up a meeting with some people that I have on my mind.
We can write about it. Yeah.
All right, excellent. So any other question from the audience? So I would, if this is the case, I would like to thank you, George, for this very inspiring talk.
Yeah.
A lot of things. I mean, even in Milano, they don't mention so many things and so many applications of the photonics. Mainly, they were very much focused how lighting can impact the cancer therapy, to be honest. But you showed to us, as Manolis Paravelakis has mentioned, a new way of thinking and new applications of photonics in various activities that they have and financial impact, as I told you. So I should close the session right now. I would like to thank also all of you, my colleague George Kavouglakis, and all of you that you are present. And we have one more Psy Cafe for this year, next Friday, and a professor from the physics department of Aristotle University will be with us in order to speak us about the research that they are doing in the University of Thessaloniki.
Thank you, Costa.
Oh, thank you very much, and see you next week.
Thank you.
Yeah, bye. Fotis, I just received the cell. I will make the correction. Thank you.
Thank you, Costas.
Bye.
Bye.
Bye-bye.